I'm Julia Smith. I'm going to be talking a little bit about inverse functions and ciphers. This is the outline of the talk. A cipher is a method of creating secret messages. It's used in everyday life, every time you check your email or do online banking, so that the information you send is encrypted so that it can't be read by a third party. The ciphers we're going to be talking about today, we're going to be talking about in terms of linear functions. A linear function has the form f of x equals ax plus b. And this is so that a is not equal to 0 and has no common factors with 26. So the first thing we do in order to use linear functions on a message that is going to be made up of letters is to associate each letter to a number. So we associate 0 with A, 1 with B, 2 with C, etc. And obviously we need a way to associate every number to a letter, since there are only 26 letters and a lot more numbers. So the way we do this is we think in terms of the number when divided by 26. So if n is an integer and it is not a number 0 through 25, the way that we find out which number corresponds, which letter it corresponds to, we will divide it by 26, and the remainder of that number will correspond to a letter. So now we have 26 also corresponds to A, 27 to B, etc. And any number, when divided by 26, for example, if the number has a remainder of 13 when divided by 26, it will automatically correspond to n. And this is just a way to write it neatly, to say 0 bar, 1 bar, 2 bar, etc. Another thing we have to look at is the inverses of numbers modulo 26. So many numbers have an inverse. The inverse of 3 is 1/3. But when we're talking in terms of modulo 26, the inverse of 3 is also 9. Because the definition of an inverse is a number when divided by its inverse will be 1. I'm sorry. I meant to say multiply by its inverse. So 9 times 3 is 27. Divided by 26, it's 1. So in these terms, we can say that 9 is the same as saying 1/3, since both will give an answer of 1 when divided by 26. Let's do an example. If we say John and Maria have fallen in love, and they're going to be apart the whole summer. They want to stay in touch, but they live in a country where everything sent through the mail will be read by a government official. So they want to find a way to send a message secretly. Before Maria leaves, they decide on a linear function, and the function they decide on is f of x equals 3x plus 1. Notice that 3 has no common factors with 26. Maria is now gone. So John wants to send Maria a letter, and his letter is miss you. He's going to use his dictionary, where A is 0, B is 1, etc., to find the numbers that correspond to the letters in his message. Now he's going to use his linear function on each of these numbers. So he has a new set of numbers, which were the numbers once the linear function is applied. And now, in order to find out which letter these numbers correspond to, he's going to divide them by 26. So once he divides them by 26, he has a whole new set of numbers, 11, 25, and so on. He goes back to his dictionary, and he looks up the letters to which these numbers correspond. So he has new letters now. He has his original message and his encrypted message. So he's ready to send his new message through the mail. He sends it, a government official reads it, but he doesn't understand it. Now it goes to Maria, and she doesn't understand it either, but she has a linear function. So in order to decrypt John's message, she is going to use the inverse of the linear function. The inverse is this, but we have a problem. When you subtract 1 from 11, you get 10. And 10 divided by 3 does not give you a whole number. So there's no letter to correspond to it. But there's a way to fix this. And the way we do that is first to think about it in terms of x minus 1 times 1/3 rather than x minus 1 divided by 3. And then we know that 1/3 is the inverse of 3. And we have another number that's the inverse of 3, which is 9, when we're in terms of 26. So in this way, we can think of this as the linear function rather than our original linear function. This is the inverse of the original. So she is going to look up the numbers that correspond to the letters of the message. She's going to apply her inverse function, and 9 times 11 minus 1 is 90, etc. And she's going to divide them by 26. We're supposed to see that. So once she's divided them by 26, all she has to do is go back to her original dictionary and look up the letters. And she will have John's original message of miss you. In conclusion, in real life, this process is done by computer software, not tediously by hand. And the bad news is that it can be cracked easily, so when you are talking about real life, it's probably going to be a more complicated function, like a nonlinear function. Thank you.
Any questions for the speaker?
You plan on using this kind of thing someday when you meet Mr. Wright?
Depends on what country we live in.
Do you have plans to experiment on nonlinear functions, like maybe a quadratic function? Or?
Not personally.
Oh, okay.
What's it wrong if the government knows he misses her?
Well, I mean, I guess nothing, but it's just an example. So I guess he would really be sending a message like my social security number is.
Other questions? Thanks, speaker.